Hello, my name is Tom Perkins, and today I have a STEM presentation for you. So let's get started. Okay, the title of my talk, which was originally intended to be given at Alvirne High School in March, is Nerd Success, 60 plus fun years of electronics, looking back and forward. I am currently the senior technical editor for High Frequency Electronics magazine, and my email is toperk@aol.com. The sponsor of this talk is the Association of Old Crows, which is an organization that's dedicated to electronics for defense applications. So let's first start about talking about some early inventors and people that played a big role in the foundations of electrical and electronics engineering. First, let's talk about Edison and the light bulb. He developed the incandescent light bulb in the late 1800s. It was a trial and error effort that involved perhaps around 300 different experiments before the right materials, the correct materials could be found. And this technology has been used for about 140 years. Today, though, light-emitting diodes are taking over. They are more efficient, considerably more efficient, and therefore use less power to generate the same illumination levels. Then he developed a phonograph, and originally the phonograph recording device was a cylinder. Then it became a flat disc, which we call a record. And now, however, the information can be stored digitally, and so that hundreds of songs or other media can be stored on a tiny device, either a CD or even a thumb drive. Now, Edison was a big proponent of direct current to distribute power to homes and businesses. And this did suffer some problems because of the voltage drops and the inability to step the power up and down. Just based on Ohm's law, the E equals IR, or voltage equals current times resistance, this posed a real problem with trying to transmit electrical energy more than a few blocks. Meanwhile, Tesla and Westinghouse developed a means to do it with alternating current. And this was better because it was easy to step the power up and down through transformers so that large amounts of power could be transferred over long distances at very high voltage and therefore lower currents, and did not present as much of a problem for the resistance of the wires. But did you know that Edison also experimented with a number of other things? One of them was the concrete houses and even furniture. This is a model of one of the concrete houses. This was in the early 20th century. Of course, Edison standing there with the model. Quite a nice, ornate looking structure. And this is one under construction next to another one that's completed on the right. This is a whole row of these houses as they exist today, I believe, in New Jersey. And they suffered some. They were very strong houses, very well built houses that could withstand high winds and things of that nature, but not easy to alter if you wanted to change a room around or something, because you couldn't tear it down like you could a wood frame structure. Okay, let's talk about James Clerk Maxwell. Maxwell developed a set of equations, partial differential equations, which you probably have not seen yet, but you will see if you pursue mathematics or engineering in college, or both. And these provide the mathematical model for electrical, optical, and radio technologies. He developed these equations just before or around the time of our Civil War here in the United States, a little after the middle of the 19th century. Now he didn't live to actually see any of this put into practice from a radio point of view, because he only lived to be 48 years old, and hardware wasn't actually developed till a couple decades or so later by Marconi, and even that was very primitive compared to what we know today, using spark gap transmitters and coherers, crystal detectors, and things of that nature. But he set the standard for electromagnetic propagation, and it was kind of off to the races after that. And this is a little more. This is his equations. I won't go into detail because you would need a little more mathematical foundation perhaps to easily comprehend these. Now we're going to talk about a Schottky diode detector. Schottky diode was named after a German physicist, Walter Schottky, and this was a sort of detector that would be used in an early radio, same kind of technology. And we're going to demonstrate that in a moment. Okay, now you all pretty much all have cell phones or smartphones, and you may not know that there are a number of antennas in those. The smartphone is actually a two-way radio in many ways, and there are antennas to talk to cell towers, to talk on the phone, to talk to Wi-Fi, and to, in some cases, receive signals from satellites, located GPS signals. So there's a massive amount of antennas in the phone, and the antennas have to be very small and compact, and are not exactly ideal, but are kind of a compromise, but they've been perfected so that they work over an adequate range to provide good service. Now what I'm going to show here is, if you look at the face of a cell phone, made a little detector, and the detector could look like this. Actually, it could be done with one diode. This has four diodes and an LED and a half wavelength dipole, okay, which at 2400 megahertz or 2.4 gigahertz is quite short. It's only about 2.5 inches from end to end. And this operates at the same frequency as a microwave oven or the unlicensed Wi-Fi in your home. So you can actually take one of these devices and locate where in your phone the Wi-Fi is, for example. And if you probe around, this is turned on here, you can see that there's a presence of a fairly strong signal in the upper right hand corner of this smartphone. If you go around the phone to other places, you don't see any signal. Now another smartphone that I have picks up a signal at in a different spot on the upper left hand side, but you can see clearly that there's a signal here, and I'm not getting it too clear. There you go. So the another means to actually look for that signal is a broadband log periodic antenna that's simply on a printed circuit board. This is really a microwave antenna that can be used for that. Perhaps a more definitive test is something like this, where you can see this is a transmitter at 144 megahertz, and you can see the light gets brighter as I get closer with this handheld radio, and I turn it off, and of course the LED goes out. So again, this is showing the principle of transmitted radio energy, and you can even show the effects of polarization. This is in line vertical polarization, and this is cross polarization, where the signal level will drop in theory about 20 dB. So getting back to our discussion, I showed some of the dimensions that would be used here at different frequencies for this dipole, and you could actually make one with parts that only cost a couple of dollars. And this illustrates how the signal drops. As you double the distance, the signal would drop by a factor of 4. In other words, it's the inverse square rule. The signal drops by the square of the distance. So it drops off very, very quickly, and typical signal strength used in a cell phone is actually quite weak, The signal strength you might find at your phone might be well over 100 decibels relative to a milliwatt. In other words, 100 decibels below that of a milliwatt. Okay, another person we can talk about is the English scientist Michael Faraday. He contributed to the study of electromagnetism and electrochemistry, and the unit of capacitance is actually named after him, the farad. And he one of the things he did was demonstrate a Faraday shield. Now, he did this actually before the middle of the 19th century, and he did it though with lightning, and demonstrated that induced lightning would not penetrate a metal enclosure. And there's a way I demonstrate this with a radio, where I put the radio inside a metal trash can, and turn the volume up well enough that you can certainly hear it with the lid on, but the signal completely goes away because of the shielding. And this is a fundamental thing which we probably take for granted, although one time when I showed this actual experiment to a younger group of kids, there was a question of whether the radio stopped working simply because it was dark inside the can. course, we know that's not the case. So a little bit about me. I got interested really in engineering in the 8th grade. I wrote a career booklet that was required, and didn't know much about engineering. I actually went to what was then a famous TV and radio host named Arthur Godfrey, and he wrote me a letter back, personally signed, encouraging me. Then I got into ham radio in my freshman year of high school. We had a radio club, and of course in those days there was no cellular activity, so this idea of being able to communicate around the world from your house with your own radio station was extremely intriguing to me. And subsequently there was a book put out, kind of a history book, about 25 years ago, and I like to say the nerds won, because the sports people at the time were not in the book, but the ham radio operators were. So I say the nerds won. And of course, well, this is actually from a video from the high school. It was made in, I think, in 1957, and this is a couple of my friends operating the radio station, which was actually in the corner of the industrial arts room at the time. I was more interested in the radio part of it than I was the wood shop. This is the radio club of the year I graduated. That's me there on the second from the right. I think I was the secretary of the club. This is what my first radio looked like. It was a regenerative receiver. It was a kit, and it worked fairly well, but it was rather primitive. It only had 3 tubes, and the transmitter looked like that. And I recently saw one of these. I didn't buy it, but it was at a flea market last spring, so they're still around. And that was a 90-watt transmitter, which I had to throttle back to 75 watts initially, because I only had what was called a novice license. This is one of my people I had an acquaintance with back in my high school days, and he won a Nobel Prize many years later, in 1993. And I got together with him a few years ago, and it was quite an experience to talk to him about his accomplishments. But he also was a ham radio operator from early in his, I think actually when he was still about in the 8th grade. This is some of my friends again in the first row here, and we were mentored by some older men who, in what was called civil defense, and this was an operation nationwide to deal with disasters, which we hoped would never come. And we were getting training from some very experienced hams that had been around even during World War II. This is an outdoor event, a flea market, much like where that other picture was taken, but this is a flea market from way, way back. You can see the Volkswagen microbus, as they used to call it. This was college. I think in my senior year. I'm on the far left there, and of course the equipment we had in those days was rather primitive compared to today's equipment. But nonetheless, we learned not just theory, but how to use electronic equipment. I had a bit of an advantage because I had already been working with things like this for a number of years at that point. Some of the folks were not so fortunate. This is why what I did and what I learned was fun. And I spent most of my career having fun because it was something I loved to do anyhow. This is back about 45 years ago, me operating a station, my station, and a couple of the towers in the back, and we won a it was actually a group of us that got together and we won a VHF, very high frequency contest. And I'm still doing that today. This is my one of my current radios, very sophisticated compared to what I showed you from the 1950s. These are the antennas in my backyard, 2 towers, many different antennas for different frequencies. There's the actual ham shack building and a model of it that my son made. My son, by the way, is also a ham radio operator. And there he is. We are at a field day and he's holding an antenna to working a satellite. Actually, we're contacting stations through a satellite, an orbiting satellite. This is my work history. I will not elaborate on it, but it just illustrates some of the many things I've done, many opportunities I had, and even when it was all over, pretty much around 2009, I was still. I had only scratched the surface. Things are constantly changing. It's an extremely exciting field. This was one of the first monolithic microwave integrated circuit amplifiers that was developed at what's now called BAE Systems, and when I retired they actually gave me one of these. I had one left over and they thought, well, you need to have this because this is the first one of this complexity. Again, more of my work. I did have the good fortune to have a total of 6 patents. All of those patents I think were earned after I was in my mid-50s, so that's not necessarily a young man's passion. It can be done in later years as you develop more expertise. So I do have fond memories. I now work with Scott Spencer, who's the grandson of the man who developed the microwave oven, and he's the publisher of the magazine. And again, I mentioned the patents and some of the other things I've done, and as I say, I've barely scratched the surface because there's constantly new technologies coming along, and the technologies today are more integrated. Mechanical engineering, materials engineering, chemistry are all interrelated with the electrical engineering, and getting a degree is just the first step, or get your whatever formal education you get is just the first step in a long road, because you would constantly want to be continuing your education. This is an example of, this is a symposium where you can get educated. This happens to be the exhibit floor, but there are many talks given at such a thing. This was last year in Boston, the International Microwave Symposium. And I am sort of retired. It's a reflection of the lake in the window of our trailer up at Lake Winnisquam. And this is my background with the IEEE. My background with the AOC, the Association of Old Crows, is somewhat similar. But I joined the IEEE, which was formerly the IRE, the Institute of Radio Engineers, back in 1962. And I've taken a lot out of that, learned a lot technically, but in recent years I've tried to give back and serve the organization in many ways as well, which has been a lot of fun too. Such as this is a trip up to Maine. This is an opportunity I had to hear a long talk from Dean Kamen, who's a local inventor. You probably know who he is. He's now working a lot with medical equipment. And this is Ralph Baer. I got to know him very well. He's now deceased, but I got to know him well, inventor of the video game. I took him to speak in many different venues. back generally in the 5 to 10 years ago, and really enjoyed getting to know him. And he was working on things right up till his passing at, I think it was age 93. So final thoughts, choose the right courses. Engineers will need to be very flexible and able to lead and adapt new processes and techniques. Computer-aided design needs to be mastered, but not depended upon for solving all problems. That's an engineer's job, is to solve problems, and you need to develop expertise in knowing how to react